The broadcast is now starting. All attendees are in listen-only mode.
All right, everybody. Welcome to our Scanning and Modeling Complex MEP As-Built BIM Project Management Real-World Best Practices webinar. Before we get going, let me go over just some of the basic rules for the webinar here. All participants are going to be muted during the presentation. I'm sure you all have great insights, questions, that kind of thing. But we ask just to keep things, going along smoothly here so we can get through to the end of the presentation, that you submit those questions and comments through the questions panel here in GoToWebinar. Those questions we'll answer perhaps some throughout the session, but a majority of them will be answered at the end in our Q&A session. Of course, this webinar is being recorded. So if you need to step away for a moment or anything like that, you're not going to be missing out. We'll send you a recording of this webinar once it's completed. Let me go ahead and introduce our presenters here. First, we have Bob Ferguson of Jaynes Corp. Bob, why don't you introduce yourself?
Hello, everybody. This is Bob with Jaynes Corporation. We're a general contractor here in New Mexico with branches in southern Colorado and East Texas. And we'd just like to thank, West Texas, that is. I just wanted to thank Chris and the entire team at ClearEdge for this opportunity to share this project with you all.
You're welcome, Bob. After Bob's presentation, we'll have John Trammell of Brandt giving his own presentation. Go ahead and say hi, John.
Yeah, thanks, Jason. Like Jason was saying, my name is John Trammell. I work for the Brandt companies in Dallas, Texas. We do close to about $500 million worth of work a year. We're a huge MEP contractor. We have offices in San Antonio and Houston and have some sister offices in Fort Worth and Austin. I worked for the company for 15 years, and I was just happy to be a part of some outstanding projects. I'm currently transitioning into a technology role that's leaning more towards augmented reality, virtual reality, really cool technology and software. So I was happy when ClearEdge team approached us about giving this presentation about some of the Edgewise end deliverables that we've had. So I'm excited to be here. So thank you, Jason.
No problem. Of course, my name is Jason Moran. I am the Edgewise product manager at ClearEdge 3D. Originally started off in 2014, basically doing some modeling and customer support work. And through the years, I've kind of risen through the ranks, and now I'm primarily responsible for the Edgewise product. Chances are, if you're one of our customers, we've interacted at some point, demonstrations, training, tech support, software requests, that kind of thing. All right, let's go ahead and move right along. First up is Bob. Take it away.
All right. Hello, everybody. This is actually a rather small project that we did for the New Mexico Community College here. They are considering actually documenting all of their campuses with both terrestrial and drone capture. And actually, they wanted to start with some boiler rooms. There's a couple of us on my team here that sit on the advisory board for the drafting program at the community college. And so it was a real nice opportunity to provide this service to them, and also use the product to introduce the students at the college to this technology. So what we're going to look at is the boiler room at the student community center. This was nice that we didn't have any timeline or really any specific deliverables available. So we offered them a Revit model and recap. So some of the project challenges were at the time just placing the valves. This is your typical boiler room with a variety of different valves on the systems. This procedure is now automated in the more recent releases of Edgewise, but this goes back a few years, so this was to be done all manually. And on the next slide, what we did as far as using, we used a Faro S150. We did 21 scans, and it was nice. We had no access or time restrictions. And I thought this would be a good product or a project rather to demonstrate as it demonstrates all the different automated tools in Edgewise. We're able to do some architectural, some structural, and then quite a bit of pipe extraction. We registered to scan in Ferguson, and we processed and modeled in Edgewise and exported to Revit. There were some significant time savings using the automated project process in Edgewise, particularly since this was a complimentary service we provided to the college to show them what technology is available. What would have been approximately 80-hour job was done in 2 days with significant cost savings. And that's it for this slide here.
Sure. There you go.
Thanks. Once we were all finished, we presented this project to the students and showed them what was available as far as data, reality capture and data extraction. And also, we now have a nice little project ready to show to our clients as far as what services we have available. What you see here is a combination of the Revit model and what's called a remainder cloud. It's a tool that's available in Edgewise. This was done specifically in an Autodesk product recap where we crop the image down to show this, but there is a tool available that we find very handy in Edgewise where you can isolate specific areas of the point cloud and combine them in with your Revit model. This reduces the size of the file significantly, and it makes the workflow a lot more efficient.
Yeah, it's one of the things I've found working with you, Bob, and a few of our other customers is, just bringing a full point cloud into an application like Revit to model, details like valves, flanges, or other, kind of detailed components can be really just a painful process. It's something that you have to do a lot of clipping away and either Revit temporarily or if the point cloud and recap like you did in this project. And it's just a really time-consuming process. So having the ability to quickly or even automatically segment a point cloud based on the type of object that's being modeled or things like that is something that we found people think is really valuable and really helpful, especially in applications like Revit that weren't originally built with the intent of modeling against a point cloud. They're design tools. It's great if you want to, design a piping system, but it's not ideal for trying to fit that piping system perfectly against the point cloud and lining up each bolt on a flange. Wouldn't you agree?
Exactly. I'll definitely agree. And if we were just simply capturing the systems to show what's there for tagging purposes or for facility management, this would be fine. What really comes in handy with the isolation capabilities of the remainder cloud is that they need to replace spools for fabrication.
Yeah, absolutely.
You're able to actually prefabricate these spools off site. So we move on to tips and best practices. It's really important to understand the tools that you're using. I've been working with the folks over at ClearEdge and Edgewise for just over 4 years now, and it's been a constant learning process. Aside from just the actual product itself, whenever you're doing scanning, you always want to ensure that you have a great coverage. Even if you're just using it as a point cloud, be sure that you sample the elements from all sides available. Break your point clouds up for use in Revit. Some of these files can get quite large. We're talking 20, 30, 40, 50 gigabytes. So being able to break them down into more useful chunks is actually quite helpful. And as I was kind of alluding to on the second bullet point, stay in contact with the creators of your tools and learn the best practices for them. I think Jason and everybody on the team there could agree that I have rang their phone off the hook several times, getting used to all the great features that's available.
Yeah, but it's something we're more than happy to work with you on, and I think that's just a great piece of advice for any tool that you can use. You shouldn't go out there and buy a scanner, a piece of software, anything, and then end up frustrated or disappointed in it without having a dialogue with the company that creates and maintains that thing. It's there's so much to be learned from talking to anyone in the industry who's more familiar with the tools than you are, and oftentimes the creators are the most familiar there is. So it's
exactly.
I think we've had a really good. We've both learned a lot from each other in discussions over the years, but it's just a great tip in general because it's so many people try something, they don't really understand it at first and they give up on it, or they don't ever use it actually correctly because they never got the training or the expertise kind of in their heads. But
yes, agreed. So as you mentioned, when we were introducing these tools to the different clients, a lot of folks don't actually realize what it is that we have available. So if you move on to the next slide, there are just a few questions that I try to ask every client, whether they have experience with the scanning or not. And that is, what is the scan being used for? What are your intents? Is this a tenant improvement? Is this a remodel? Is this to document systems that have been installed? And what elements do you need to see? If it's just a space and you're looking for 4 walls and room, available real estate, or do you actually need to see down to the level of bolt patterns on flanges, and what you need to be included? And need is bolded there as once they see what's available, oftentimes clients, they want everything, and we all know that that's more time, and time is money. So if you can just sort of kind of hold their hand through the process and say, well, this is let's capture what you need, and if the budget allows and you need more later, it can always be enhanced. And then what is the level of detail needed? Again, if you're just looking at the space itself, then we're not really interested in the detail of the mechanical systems. You could go through it a lot quicker, but if they need to see signage, if they need to see the handles, things on the valves, for lack of better words, then that's going to take more time too. So find out exactly what level of detail they like to see and what's the deliverable. Are they looking for a Revit model? Are they looking for just a viewer to see the point cloud in? And then these 4 questions are awfully open to conversations for more information.
Sure. Go ahead, Bob. Sorry.
Go right ahead. That's fine.
One of the things we've learned through conversations with our customers, potential or otherwise, is we always get excited about laser scanning as a whole, being kind of the adoption of laser scanning, and the more people scanning, the more potential customers we have, of course. But it's always surprising kind of what people do or don't know about laser scanning and what's possible and that kind of thing. It's as silly as it sounds to those of us who are really familiar with the technology. There's plenty of people who think that laser scanners see through walls, right? That you don't need to take the drywall down to scan the studs, and it's just not true. If you want to scan up in the ceiling, that's a lot of work. That's not just putting the scanner down on the floor and hitting the button. And that's always setting those expectations and just educating people about what the technology is capable of, whether it be hardware or software, is a huge part of them seeing the value in the technology. And in your case, it'd be, getting the gig. If they don't see the value in scanning and, BIM and the whole ordeal, then, are you going to get the job or
Agreed.
not? Right.
Agreed. And there are definitely some limitations, as you pointed out, with visibility behind walls above ceiling spaces. So a lot of folks do think that this is X-ray or that this is sound, sound penetrating. But yeah, letting them know what the limitations are so that they're a lot happier when they see the final product.
Yep.
And what we ended up with was a real nice scan of this existing boiler room that we were able to share with the students and educate them as far as what technology they may run into once they've graduated, and provide the facilities management team down at the community college with an example of what's possible as far as identifying their systems, tagging them, and actually, if there's need be, potentially prefabricating them.
Yep, absolutely. That's one of my kind of my favorite parts of this whole project. Just being an observer of it is, you at the end of it, you have a tool both to educate your potential clients and customers on the benefits and the kind of reality of scanning. But it's also was a tool to educate students on new technology.
Yes.
Certainly, education's great, but community colleges and the like aren't always totally up to date on the technology they're teaching about. I've certainly been there myself, and to go in and kind of show them the real bleeding edge stuff is, that's going to be hopefully incredibly popular in just a few years here, and see widespread adoption is probably really beneficial for those students, which is certainly something I can appreciate.
Absolutely. Our program here is a 2-year associate's degree, and it's just difficult to cram into 2 years everything that is available in the reality capture world. And kind of with that, I'll let it go over to John and let him talk about his stuff. But like he mentioned, with the virtual reality and augmented reality, there's just a lot to cram into 2 years. So,
sure.
Thank you.
Yeah, thank you very much, Bob. John, why don't you take it away here, and then after that we'll have a Q&A session. Feel free to send any questions you have into the questions tab on GoToWebinar here. John, take it away.
Okay, yeah, thanks, guys. So my project was scanning and modeling underground piping at a hospital here in Texas. And this project is it was kind of unique because they're doing a renovation of the hospital. So what that meant for us is that they're going to add some Starbucks, and they're going to add a bunch of bowling alleys and things of this nature, but they were going to need to require us to tap into their existing utilities. The problem for us are these pipe tunnels were absolutely old. I mean, this just insulation was falling off everything. Nothing had pipe labels on it. And so at the time, we've never even scanned a project before. Oh, can you please go back?
Oh.
I apologize.
Sorry about that.
Oh, that's okay. Yeah, we've never even scanned anything before, and so basically what they asked us to do was they hired us to come in and do a laser scanning to see if we can label some of their existing utilities in these pipe tunnels that had miles of piping, and they wanted us to turn that into a Navis model, and ultimately we needed to use that same model for prefabrication. So the end deliverables that were required from me to our BIM department was we were turning over point clouds and the converted models. And when I say the converted models, I mean the models that we were able to use with Edgewise, convert from our point clouds. We were able to generate point clouds from our Faro software, and we used that into Recap as well. We use Navisworks, and we use Revit, and we also use Fabrication CAD MEP. And so the end deliverable to the client was as-built shop drawings. So they wanted drawings of their existing utilities, what pipe sizes and what they fed. And then ultimately we use fabrication spool drawings to send out to our fabrication shop to get fabricated. Okay. So some of these challenges, like I was talking about earlier, is because this was an existing part of the hospital that was built in the early 90s, they didn't even have anything close to a 3D model or even a contract document to get us a starting point. So everything pretty much underground was an unknown for us. And we need to figure out how that existing pipe tied to the other pieces of equipment in the hospital and what we needed to shut down in order to tap into those existing lines. So the project challenge, it says that one small room turned into 7 different projects. So how can that be a bad thing? I say it was good for us, but it was a bad thing because I wish we would have known that all of these 7 projects were going to tie into each other at the very beginning. What happened was we did this little piece, then we did this little piece, and then they were happy with it, and the client wanted us to come back and do this little piece. And so we were just gaining their trust more and more during every coordination meeting that we were having. And so some of the issues that we were talking about, that Bob was talking about earlier, were, getting some of the valves to convert over. I learned the flanges. I learned the tricks of the flanges. But like Bob said, the new releases of the Edgewise software, it was able to give you valve updates and make that easier installation for us. Again, some of the issues I was talking about earlier are the issues with the insulation and the pipe sizes. Hindsight being 2020, if you can identify your insulation thickness and your pipe size somehow in your laser scan, I strongly suggest that you do that.
That comes right on back.
Oh, go ahead.
That comes right on back to scans not being able to X-ray stuff, right? You scan the outside of that insulation and you have a good idea of how much space is taken up, whether that's a 2-inch pipe or a 4-inch pipe or a 6-inch pipe under there, with, of course, they have varying degrees of insulation. That's a huge mystery that you have to solve, especially if you're going to be creating fabrication drawings to tie into that, right? It's you kind of really need to know what's under there, and that's not immediately apparent from the scan all the time, almost none of the time, in fact, right? It's totally insulated. So that's definitely one of the things you can do out on the site, or if you can get a scan of an uninsulated area to really kind of streamline that process and prevent that headache. That's a really kind of a big deal, right?
Oh, absolutely. And like I said, when at the very beginning of this project, we delved headfirst into this thing. I'm not going to say that we sold our customer a bill of goods, but I am going to say that we may have extended the truth on our current capabilities. And so, we were definitely learning on the fly, and the learning curve was huge for us. And like I said, hindsight being 2020, I would have identified and penetrated every single piece of insulation for every piece of pipe that you see here on the screen, to make sure that it was clearly conveyed to me as I was trying to do my conversion through Edgewise. And then the last part there was not realizing that. No, that's fine. That's fine. You don't have to go back. I was just saying the last part was, part of what they hired us for is that we were constructing a little central utility plant right there. So some of the pipe that we had was existing, and unfortunately, real world conditions don't allow you to hang everything perfectly at 90-degree angles or 45-degree angles. And Edgewise is so accurate that it really taught us the stuff that we even installed ourselves might have been at an 88-degree angle or might have had a little bit of slope on it. So being able to convert that through Revit and through Edgewise was a little bit difficult because our software wants to draw everything in perfect 90-degree angles or perfect 45-degree angles. In reality, it's just not that. And so you have to have that discussion with your team about, are we really trying to capture the real world conditions? Or are we trying to do what our computer can handle?
And whether or not you're tying into that at the end of the day is a huge part of that discussion, right? If you're delivering a model, that's one thing, but if you've got to put something new in there and make it work, it kind of paints that conversation in a whole new light.
Absolutely. So just some of our workflow, the data capturing. We purchased a Faro Focus S350. I think it's a very powerful scanner. Not here to promote that. It's just a really good tool. It took about 30 to 35 scans. We did target registration. So those that are familiar with the laser scanning, you can have targetless or target registration. We felt that because it was in such dark areas, in such closed areas, it was best for us to have target registration. So we literally hung targets up on the wall. That way you can identify them from scan to scan, and that's how you mesh your point cloud together. So data capturing, obviously they hired us to come in and get any architectural, structural, all the pipes, existing valves, and fittings extracted with the Edgewise software. And then the back to the office processing, we did Ferguson to Edgewise, and then we went from Edgewise to Revit through their little add-in, and then we had to go from Revit back to our fabrication software. So, we don't really live in Revit. Our engineers live in Revit, but our team, the VDC department, they live in the fabrication AutoCAD CAD MEP software. And for us, that's what holds the intelligence to send to the fabrication shop, which works with our internal software that we have that feeds our fabrication shop. So it was imperative that we had to go from Revit to fabrication. And then back for the end deliverable to the clients, we exported out an MHA from fabrication and put that back inside of Revit. And that way our client could make that part of their Revit model. So we literally had five different models of this. And so that's kind of what happens to the last part, and why we'll touch on that a little bit later on why some of our file structure was so huge. And then let's see, we used a single dedicated computer for processing. And I suggest that you do that when converting point clouds and doing these Edgewise models, because they can get cumbersome. They can get very large. And you are going to receive phone calls from the IT director when your file structures are 186 gigs a project. And so I can contest to that myself.
Yep. One thing I want to kind of double back on here is the targeted registration. In the same way that using an as-built modeling tool like Edgewise will enlighten you to kind of all the nasty little details in the real-world facility, and all those slopes and angles that aren't quite what you thought they were. Tools like Edgewise also really help you understand just how good you are at, or your process is at accurately registering the data. If you're, you can be a few, a centimeter or two off, maybe a few millimeters, somewhere in there, and not really notice it just looking at the point cloud and visually modeling against it. But if you're doing any kind of work processing the point cloud data and automatically kind of determining results based on that, it's absolutely imperative that you have very tightly registered data. And if you have issues in your process there, it'll become very apparent very quickly. So it's this was your first project with laser scanning, but you got really either really lucky or you're just really smart in figuring out that you needed to do targeted stuff in this place, because if you had done cloud to cloud, perhaps as a beginner, you may not have really gotten the results you needed to be effective.
Yes, and so we were able to do, I said this was our first major project to scan, and so we were able to do some internal testing with some targetless registration and target registration, or even the cloud-to-cloud registration like you were talking about. So we realized through some previous scanning, not for a client that somebody paid us to do, that we figured that target registration was the best way to go. And you're absolutely right. Not only will that precision help you when you go to create your recap file, it also helps you when you come in here to the Edgewise software, and it's damn sure going to help you when you send it out to the fabrication shop.
Absolutely.
So, again, I told you from the beginning that we had to dive in head first on this. I mean, we had to have a turnaround project in 2 weeks. And so, we risked it and told them that we could do that with just a few videos and some trial versions that I was able to do with Edgewise. And it was just enough to build my confidence to say that we could do it. And ultimately, we delivered on that promise. It would have easily, and I'm just being conservative here, it would have easily taken us 8 weeks, if not more, possibly 16 weeks to go in there and measure out everything that we were able to capture in Edgewise with the tape measure. Because that's the only way you were going to be able to do that, is send a crew of guys down there with the tape measure, record all that down, and write it all down on papers, get their isometrics, and then bring that back in for us to put it inside of a model. Huge time savings for us. And we were also able to save conservatively another 25,000 just in the virtual design destruction portion of it. And that means bringing that data in and processing that data and creating all those models for all 5 different softwares that we were able to use. There's no way we would have been able to do that without Edgewise. And again, at the bottom, Edgewise made the project feasible, and that is not an exaggeration.
Yeah. Yeah, just you can see it in the background of the picture on this slide here, and it was also in, I think, the first slide of this set. There's that kind of long hallway that must have, 100 1-inch, 2-inch pipes on each side of it running down the length of it. I couldn't imagine trying to pick those out manually or recreate that accurately manually just based on a set of measurements. You'd have to be incredibly detailed and precise in the position of those.
Yeah, and I would, not to interrupt you there, but yes, that was actually conduit. And so the reason I wanted to bring that up is because you know how many bins are inside of conduit. There is no way we could have actually captured those real-world conditions with the exact bins in the conduit the way that we did with Edgewise.
Yep, absolutely.
So, some of the tips and best practices for us, and we've already talked about it. When using target registration, make sure that you can see at least 3 or 4 targets in every scan. Those targets are so important to the accuracy of your scan, which is the foundation of everything that you do. If you do not have a good scan or in a good point cloud, everything else is useless. So it all starts there. And so when we send our team out there, I make sure that 3 or 4 targets at least. So wherever they go set up, what I mean by that is from each scan position that they set up, they need to clearly be able to see in a 360 view at least 4 targets that we set up on the wall. And that's really going to help you on the back end when you're processing and registering your data. Take time to read the instructions and follow them. I'm a typical guy. I work with a bunch of guys that follow that same method. They just dive in head first and then complain about it later. We didn't have any choice because of the time frame on the project, but just take the time. They have such good videos online, YouTube videos. You can even look at the Edgewise training videos I think that Trevor put together. They're amazing. Just take the time and do that up front. And then what I talked about earlier was identifying insulation thicknesses and pipe sizes. It will save you so much time. Not to have to do the guesswork and to be able to convert that pipe with the internal pipe size inside of the insulation and then adding the insulation thickness on later is what I would do to save so much time next time. And then the more tips and best practices is we were able to overlay our new MEP model to enhance the coordination of the spaces and the communication issues. So kind of like Bob did, and he was saying, is that you get to bring in the point cloud to show the real world conditions with your model. And so I strongly suggest that you do that. I mean, I think that's the whole reason why we use the Edgewise software to begin with, is to make sure that we can bring the point cloud and add our CAD MEP software, piping, HVAC duct, the conduit that we had, and let our clients see what it would look like in the exact real world conditions that they have downstairs. Make sure to back up your data. I may have been guilty of not trusting to delete the data. That's why some of our file sizes are that large. Again, and another reason why our file sizes were that large is because, back to my original comment of us having 7 projects, we had to set up 7 different little projects just to make one project. And if we would have known all this together, I think it would have significantly cut down on the RAM and the memory that it was eating up. And then have a separate computer to process that data. I think it's worth the investment. When you're processing data, you could literally sit there and just watch that blue circle, and it will give somebody the excuse to go look on YouTube or something like that. And so we try to eliminate all those excuses and have a separate computer that is just strictly used to processing data and running the Edgewise software and the recap software that we use.
Absolutely. There we go. Thank you very much, Bob. Thank you, John. We have quite a few questions that have rolled in over the course of the presentation, so we'll start working down that list now. The first of which is about remainder cloud that Bob and I discussed. does the remainder cloud show up in drawings? So of course, in terms of Edgewise, remainder cloud is output as either a PTS or an RCP file, which you can then load into AutoCAD or Revit or another application. I'm not sure if printing from Revit or AutoCAD includes the point clouds in them personally. Do either of you have any experience with that?
I can address that question, and John, please feel free to chime in also. If you choose for it to show up, yes, it can. I don't know what the determining factor is, but for those of you familiar with Recap, you can produce an RCP or an RCS file. The RCS will not plot, the RCP will. And you need to be sure if you're using Revit to have your level of detail set to fine. And then you'll be able to plot your point cloud.
That's a little bit bizarre that it does it with the RCP and not the RCS, but
I don't know what Autodesk hasn't given me an answer that I've been able to wrap my head around yet either. But yeah, that's one thing we did learn.
Sure. We have a second question here about getting valves and flanges in Edgewise to align with the as-built dimensions. Is it related to the pressure assigned? Yes. So in Edgewise, there's a custom standard editor where you can either, because of course there's always going to be some, at least one in every project, one weird valve or flange that just isn't anything like what's in your standard library. It seems like our custom spec editor allows you to basically custom define the dimensions of the valve or flange. And of course, if you update the pressure rating for a valve or flange in Edgewise, the dimensions are automatically updated to match that. Let's see. Are the black elbows from Edgewise built from the point cloud or part of Edgewise's assumption? They are a little bit assumed on Edgewise's part. So Edgewise will extract the cylindrical data, the pipes, the conduit, the round ducting, and we have connection tools that look at the distance and the angle and the size of the pipes to determine which ones should be connected there. Of course, we do have the tools to easily make sure that's lined up against the point cloud and accurate. Otherwise, it's kind of a moot point. It's a question here that says, we've had issues with tunnel temperature causing the scanner to alarm us. On internal scanner temperature, I'd have to remove the scanner from the tunnel to cool it down between scans. Did you bring in outside air or fan or use any other products to remedy this while scanning in the tunnel? I guess that's pertinent to your project there, John.
Yes, no, I've heard about that in extreme temperature, so it must have been in a hot environment that they were in. I just got back from some Furrow classes, and they were saying, you either take it out and warm it back up, or you take it off and go put it in the air conditioner and kind of cool it off a little bit. Fortunately for us, we didn't really encounter any of that because it was an existing hospital in some areas. I mean, it did have some good clean kind of cool air conditioned conditions. So it wasn't the pipe tunnels with the dripping water and the black mold growing in the corner. So the temperatures were okay for us, and we did not encounter that error message.
Yeah, I've definitely seen like scanner cozies and the kind of thing for cold temperatures, but aside from pointing a fan at it or maybe encasing it in a block of ice, I don't think there's a lot you can do for hot temperatures. So that's a good point. Because we're stressing how important it is to identify insulation and pipe sizes, do you have suggestions on how to do this? John, do you want to kind of expound upon your process there a little bit?
So yes, if you could break away maybe a foot of insulation back, maybe 18 inches back from an elbow on a system, and maybe do that at the start and the beginning. And then we've designed these little almost I'm gonna say like thermometers that you would stick in the insulation, that they're just measuring sticks, and you can leave those in the scan, and it will tell you how your depth of that stick. And it's just a lifesaver when you can come back and look at that. So at the beginning of it, you can, on that bare pipe where you cut back the 18 inches, I would recommend you actually writing the service or getting a label and putting that on the bare pipe itself, and then reference that with the insulation thickness. And obviously you'd want to do this in different, where the pipe size changes as well, if you can rip back the insulation. If not, then you need to get a label on the outside of the insulation and then use that with the measuring sticks.
Yep. Of course, in your case as well, there was, you said no existing documentation of the tunnel. And of course, existing documentation isn't always completely accurate, but being able to get a hold of that documentation to cross-reference it with your scans is probably a huge benefit as well. You can see at least what was originally there, some of which should still remain and should give you decent evidence as to the exact spec of the pipe under the insulation if you can't cut away or otherwise see an uninsulated section, right?
Yes. Yeah, obviously, if you have anything to refer back to of existing documentation, you want to utilize that to your fullest advantage.
I can chime in on that also. John, I bet you can agree with me. You learn to be quite inventive when you find yourselves in these conditions, and it's really helpful to think outside the box. We've often found ourselves needing to measure the insulation also, so I've taken welding rod and nicked out centimeter and inch marks on the welding rod and stuck it into a point where I hit the pipe, and that gave us an idea of what the thickness was. So don't be afraid to think outside the box.
Like checking your oil.
That's exactly what I'm talking about. Yeah, a dipstick almost. And yeah, a welding rod is a good example of what I'm trying to talk about, that just has measurements of inches on there. Absolutely, Bob.
All right, next question is, how did you guys manage the 186 gigabyte file size, and how long did registration take for that?
Well, luckily for us, we're a large company, so our IT department is well prepared for that. And so the 186 or 68 gigs that we had, it never really slowed down our servers. And again, there were multiple projects inside of each other, and so it does not take that time. It does not take any additional time to process those data, that data.
Sure, not like 186 gigs of straight scan data would take quite a bit longer to register and process, right?
Yes, and absolutely. So you're talking about, a lot of that was eaten up by the Navis models that we created, the Revit models we created, the Edgewise models we created. But to straight process the point cloud, and the scans that we had, it took no time. We only had 35 scans, and then if you break that down into the jobs that we had, we were really only trying to match and to register no more than 4 or 5 scans in any given project.
There's one person here asking for clarification, saying, is Edgewise seeing the insulation and not the actual pipe? And that kind of comes back to exactly what we were talking about with, getting good coverage on your object, setting expectations for what you can and can't scan. Is Edgewise really is only as good. I hate to kind of break the illusion here. It's really only as good as your scan data. If your registration is bad, if your coverage is bad, if you just didn't scan entire sections of a facility, then no software in the world can automatically create anything there, or create anything there at all automatically or otherwise, right? It's a completely manual process, and you're guessing 100%. And unfortunately, insulation is the exact same. We will see that there is an insulated, or not insulated, we'll see there's a section of cylinder there, which may be 16 inches, whether that's an actual 16 pipe or a piece of insulation that's 16 inches in diameter that has a 14 or 12 or 10 inch pipe underneath it. Is your guess is as good as ours in terms of automatically creating it.
If I could just add to that, Jason, LiDAR technology is line of sight. So it's only going to see what the human eye can see. It doesn't have any X-ray or ultrasound capabilities. So no software is going to be able to see below the surface of any object using LiDAR.
Yep. Yeah, and it's a simple enough operation to change the diameter of the pipe in Edgewise. You type a new number, but figuring out exactly the right number to type in there so that your fabrication drawings actually have the right diameter on them so you can actually tie into it in the real world, that's kind of the challenge. It's a simple operation. It's kind of a head scratcher if you don't do the data collection up front to figure out what the actual pipe diameter is there. Is Edgewise a multi-threaded program? Certain aspects of it certainly are. A lot of the automated processing is multi-threaded for maximum performance. There are certain aspects that are not multi-threaded that are less performance intensive, but where it counts, yeah, we're multi-threaded. And the minimum workstation specs, it doesn't take a lot. You need a dedicated graphics card, enough hard drive space to hold all your scan data, decent, recent maybe i5 or i7 CPU. Of course, the more RAM, faster the hard drive, the better the CPU, the better off you're going to be. But you can run Edgewise on a $900 Dell laptop if you need to. Is Edgewise just for the MEP industry, or could it be used for creating as-built models of industrial facilities with conveyors, other material handling equipment? Edgewise does quite a bit more than just MEP. We'll also create structural objects, I-beams, concrete columns and beams, wood columns and beams, wall and window extraction, and surface extraction, ground surface are all in there. But for specific kind of mechanics like conveyor belts and the like, probably not the best tool. Of course, Bob, I know you do a lot of architectural stuff most of the time.
We do a lot of architectural, some structural, some MEP, and it's a good point that you brought about the ground surfaces. We've actually done some really interesting topography work with Edgewise. And it's you're able to create, I believe it's a DXF, Jason, to import into Revit to create a topo surface.
Something like that. I forget the exact file format, but we do have a workflow there for turning the Edgewise ground surface, like you said, into a topo surface. Yep.
But I think it's a DXF. But yeah, that works fantastic. We've done that several times.
Yep. The next question is somewhat similar, asking if how the beams and walls were extracted. And I believe for both of you extracted both the structural and architectural elements there through Edgewise as well. Is that correct?
Yes.
I'll let you go first.
Yes, we did. The wall and pipe is automated, and the structural and the duct work is semi-automated. And what I mean by that is, instead of the computer just automatically extracting it, all you have to do is draw a window around the item that you want to be extracted, and then the computer does the program does the rest.
Yeah, just to kind of expound upon that, in Edgewise, or let me go back a little bit, in Revit or AutoCAD, to model a pipe. In AutoCAD, you may pick your cylinder tool. You'll draw a cylinder, but you have to manually define the length, the size, the rotation, the position, every aspect of the cylinder to get it to match the point cloud. In Revit, you pick the type of pipe you want to draw, you pick the size, you draw it, and then you're fiddling with it to line up against the point cloud. In Edgewise, you'd select a region of the point cloud, tell it, I think there's a pipe here, and in just a second or two, Edgewise is going to figure out the exact position, rotation, diameter, length of the pipe based on the point data that you selected and place it for you. So it's the same for structural objects and for wall objects as well. It's basically just picking out the section of the point clouds and the type of object you want to extract. The rest is done automatically. Do we offer cloud-based processing? Not at this time. Of course, cloud-based processing would be wonderful. It's just not something we're doing right now. Is there a lower limit to pipe size that Edgewise can recognize? Is there a minimum distance for it to register? Feel free to kind of prove me wrong here. Based on what I've seen, Edgewise can extract reliably down to around inch and a half or 2 inches. Of course, the semi-automatic tools that we just discussed can pick things up down to a quarter of an inch. If you go any lower than that, you're going to have trouble even having enough scan data on it to register it as a cylinder. Is that your guys' experience as well?
Yes, I think, we had no issues, even like you said, with some of the auto features that were there, going down and handling 1/2 inch and 3/4 inch conduit pretty easily. But like I said, if you're trying to capture pneumatic tubing that's a 1/4 inch or anything less, 3/8 or a 1/4 inch, you're going to have a hard time just having enough scan data around it just for even Edgewise to do its job.
Sure.
Exactly. Yeah.
And that comes to the second part of the question, which is there a minimum distance for it to register? Of course, the farther something is away, the less points it has on it. I think after about, of course it entirely depends on the scanner you're using, after about 40 meters, the scan data becomes relatively unreliable for automated extraction. So we recommend having a scan position, within 40 meters of each other. Of course, if you're scanning indoors, you're probably going to be, more than good enough, because you're going to have to place scans in doorways to go to the next room and things like that to have it all register together. But of course, it all comes down to the number of points on the object. The farther away it is, the smaller it is, the harder it is to get a bunch of points on it, which makes it harder to extract. Next question, did you only focus on pipe round systems, or did you also capture and convert mechanical or rectangular systems going into Revit? I'll let you guys take that one.
In this particular project, I believe all of our ductwork was round. Remembering back off my memory, it was all round. It was just venting coming off the top of the boilers. But you can certainly do rectangular extraction on ductwork or other MEP systems, yes. It doesn't have to be cylindrical.
So, yeah, we had some rectangle duct with the taps being cylinder ducts coming off of it, and it gave us no issues. Again, we were kind of in pipe tunnels and in confined areas, so we only had maybe 2 main runs of duct that ran on top of those rack systems that you were seeing there, but they were absolutely rectangle duct.
Mm-hmm. Yep. Next question, does Edgewise see electrical wires? Cylindrical conduit, yes. Wires, I suppose if you got enough scan data on a wire, perhaps Edgewise would extract it. It does sometimes with sections of hoses if they're straight enough, but you're gonna run into the same problem that you'd run into with small bore piping, that you're just not going to get enough point data there to capture an electrical wire. Is there a webinar specifically for architectural restoration and renovation projects? I'm absolutely sure we've done a webinar like that at some point in the past. After this webinar, I'm sure we can pull that one up out of the archives and send that to you if you're interested. And of course, there's always room for another webinar like that in the future, so stay tuned. Is there an option for Edgewise to extract pipes of different diameters or more? For example, pipes which have a diameter more than 3 inches. Basically, yes. Edgewise, by default, is going to extract basically every pipe or cylinder that it can find in the scan data, and let you classify those and choose whether or not to keep those. But we provide great tools to sort through the pipes in the model based on their diameter, their length, the point cloud coverage on them, and select and delete the pipes you don't want. So you don't have to go and find all the 3-inch pipes you don't want manually. Edgewise gives you the tools after it's found all the pipes to turn it back a little bit and only keep pipes above or below a certain size based on the requirements of your project. I know for you guys, you're probably modeling oftentimes pipes 2 inches and above for your projects. That seems like a pretty common scenario.
Jason, if I could just add to that, and I think John would agree, I'm sure he's used this tool on his project. For that person's question, they might want to contact someone over there at Clear Edge and have someone show them quick sheet.
Smart sheet.
Thank you. I'm sorry. Yeah.
Sorry.
So show the quick sheet option. That's a great tool that comes in handy.
Absolutely. Next question is, our file sizes are getting out of control as well. It's not a problem for us. However, delivering the end product to the client is. Has anyone found a way to reduce the size of point clouds for a deliverable? For that, I personally have two answers. The first is decimate it. Again, it depends on the deliverable. If they're going to be modeling against the point cloud, delivering a heavily decimated point cloud is maybe not a great idea. But for certain deliverables, it's certainly going to be acceptable. The second is, again, remainder cloud, or the Smart Points tool in Edgewise, which allows you to export. In the case of remainder cloud, it's all unmodeled objects in Edgewise. So if you didn't model valves and flanges, or you didn't model walls, the points for those objects are going to show up in the remainder cloud. Go back to that slide in just a second, perhaps, and take another look. But the objects you did model show up in Revit as intelligent objects. Everything else is in the remainder cloud, which is much more lightweight than including the full point cloud in the deliverable. Alternatively, we have the Smart Points in Edgewise, where you could select a pipe model or a structure model and export just the points that correspond to that pipe or structural object, which again is much more lightweight and gives you basically only the important points based on what you're interested in for the deliverable. Has that been your experience as well, John, Bob?
So I'd like to touch on that. We struggled with that mightily at first, and with us being in the MEP industry, the end game for us, like I was saying at the first slide, is for coordination. And so our general contractors, and I think that most of them tend to have and own Navisworks. So the best way for us to share point clouds with a client, but outside of Clear Edge products or outside of the Edgewise models, is to publish that model inside of Navisworks. And when you publish that model, there's a little option to embed point cloud data. And if you do that and you can save that as an NWD, then that general contractor or your client or whatnot should be able to append that NWD file into any Navis NWF file that they have. And I think that is by far the easiest way to share point cloud data.
And I'll just concur with both of you. Those are all, the decimation, the remainder clouds, and the NWD is an excellent advice to use. So I don't have anything on top of that.
We're running out of time here a little bit, so I may skip over a few questions here. Just know that if we skip your question, we will follow up after this with an email kind of explaining things in a little bit more detail. We have a good one here that says, sometimes when we scan, we're limited to floors, catwalks, platforms. Facilities do not want to build scaffolding for scanning. Have you done any drone scanning inside a facility? I have not. Have you guys?
No, I have not in the facility.
Yeah, yes, we have. I'm not personally. I'm not the licensed drone pilot for our company. We do have 2 or 3 licensed ones, and they have performed indoor. And I'm sorry, I don't know the model of the drone that we use, but yes, we have performed indoor drone scanning.
Yeah. I can speak for Edgewise. Drone data is certainly not ideal for automated extraction. However, there are certain hand scanners, like the dot product scanner, that are a little bit more feasible to get in those tight or otherwise inaccessible spaces and do some scanning. That if you're really having trouble accessing an area with a tripod scanner, then that might be a good option. Does Edgewise understand the different types of connections between pipes and valve? How about valves? Edgewise has a certain kind of catalog of connections that and valves and flanges that we can create basically, when we export those to Revit, and Bob, I know I worked with you before this functionality went out to try and kind of see if it was helpful, was when we create objects in Revit based on our connections, those families are basically tailor-made to be switched out with whatever family you want, while keeping the connectivity in the Revit system and that kind of thing. So we kind of create a generic gate valve or butterfly valve in Edgewise, but if you want to change that out for a much more specific family in the end application, or Revit in this case we've been discussing, that's something that we've tried to make as easy as possible, because there's no way we can possibly predict exactly which family you're going to want to use. There's so many out there. Everyone has their own custom ones. We prefer to make it as easy for you as possible to do that customization. Any thoughts there, Bob?
I was just thinking, it'd be impossible to have the entire library of valves that are available. I think the idea is to get the valve in the right place. That's the most important, so that you know where your connections are in real life. Once you have that identified and you bring it into Revit, as long as you're able to delineate the termination of the pipe to the connection, whether it's a flange or a sleeve or a socket, then you can bring the actual valve in. So yeah, it's more for exact placement than it is the exact valve.
Sure. Well, that's about all the time we have. We're at 2:01 here. Like I said, any remaining questions, we will happily follow up in email, just to kind of close the loop and finish off any loose threads here. Bob or John, do you have any last thoughts before we close out?
I just want to say thank you guys for attending.
Yep, thank you also. I have to agree with a lot of John's points. He brought us some really good, some good things there. But nope, all good here.
All right, Bob, John, thank you so much for presenting today. I think this was a really wonderful presentation. For everyone attending, thank you as well. Really great questions this time. These webinars are always kind of a joy to go through and interact with the industry as a whole, people looking for cutting edge solutions, and kind of just the discussion that happens between, software, the engineers using it, just the whole shebang is always a great time. So with that, thank you everyone for joining us, and we'll see you on the next webinar.
Thank you.